Hello, I was just going to work through the graded exit slip so that if you wanted to see specific feedback on a problem, you can just fast forward to whatever problem that is and kind of look at the information that you wanted. So solving by completing the square requires that it is an x squared plus bx equals c form. So what we're going to do is we're going to move the 12 over, and we're also then going to end up dividing by 4. So we get x squared minus 3x equals negative 3. Once it's in this form, what we're going to do is we're going to write plus blank on each side, and we're going to use completing the square to figure out what goes in that blank. So we're going to do b divided by 2 squared. So it's actually adding 9/4 to both sides. Notice that it's adding because whatever I do to one side, I have to do to the other side to keep my equations balanced. Then what I do is I write this in factored form, which is going to be whatever b divided by 2 is, so it's x minus 3/2 squared. And I can find common denominators and simplify that to be negative 3/4. Once this is written as a quantity squared, what I can do is go ahead and square root both sides. I get x minus 3/2 equals plus or minus, and I'm going to take the square root of negative 3 and I'm going to take the square root of 4. So my denominator becomes 2 and my numerator becomes I root 3. The last thing then is to move the 3/2 over. So this should be x equals 3/2 plus or minus I root 3 over 2. For the quadratic formula, you got to get it equal to 0. And then you're going to plug it in, so x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So just be careful here when you have minus this negative. This is going to end up being 9 plus 40. So your discriminant here should be a 49. Once you get 3 plus or minus 7 over 4, then these are all rational answers. We should be able to come up with actually two concrete answers for this. You cannot leave it as 3/4 plus or minus 7/4. So 3 plus 7 is going to be 10 over 4, and 3 minus 7 is going to be negative 4 over 4. And so then 10 over 4 becomes 5 over 2. Negative 4 divided by 4 becomes negative 1. For this next one, you can solve it using any method. If you want to distribute that out, that's totally fine, but then you are going to need to use your quadratic formula to solve after that. Or you could use completing the square. Right now, though, it's set up in perfect form. If I were to get my x squared term alone, I would then be able to just square root both sides. So what I'm going to do is I'm going to move the 4 to the other side, and then I'm going to go ahead and divide by 2, because now I have x plus 3 squared equals 8. That lets me just square root both sides and simplify the square root of 8 as 2 root 2. Then I'm going to subtract the 3 to the other side to get negative 3 plus and minus 2 root 2 as my final answer. And if you use your quadratic formula after distributing that out, you should get the exact same thing. For number 4, we're going to put this in vertex form, and I'm going to show completing the square. So looking at this one, when you are putting it in vertex form, it's going to be slightly different than what we did with the very first problem. You're going to group the ax squared plus bx term together. You're going to take your a value and you're going to factor it out of both of these to get x squared minus 4x, and you're going to leave a plus blank. We are only grouping together the ax squared and the bx term. So the plus 9, the c value, stays whatever it is. Then, whatever I'm adding to this side, I have to subtract because I'm on the same side of the equation. It's different again from number 1 in two ways. For number 1, what we did is we divided by our a value at our very beginning. This one, we're not dividing by our a value, but rather factoring it out. Then it was different because we added to both sides because we were on opposite sides of our equation. This one we are adding and subtracting on the same side to keep a balanced equation. So then to finish this problem up, now we're going to do b divided by 2 and square that. So we're going to be adding 4 here. And then when we do the minus blank here, we want to make sure that this coefficient of -3 also goes on that minus blank. Because now the -3 stays out in front as our a value, and we have x minus 2 squared, and then minus this negative is going to end up becoming plus 12 at the end here. So my k value of my vertex is 21. So if I were to graph this function, my vertex would be at 2, 21 with an a value of -3. If I were to graph this function, the original function using -b over 2a, I should still get a vertex of 2, 21, and I should still have an a value of -3. So it should be the same graph for both of these. On the back side, this went much better here. Looking at these ones, b divided by 2 squared is going to be what our c value is. So it should be 9 over 64. For example 6 here, the discriminant is purely b squared minus 4ac. You are not going to write the square root. The discriminant is just the radicand, so the part under the square root. So for this one, when we do -5 squared minus 4 times 2 times 11, we end up with 25 minus 88, which is going to give us -63. For this one, because it's negative, you are still going to end up with two solutions. It's just that your graph is going to look something like this, and so your solutions here are going to be imaginary. And that is because you are taking the square root of a negative. For our last two, our goal was to factor, not to solve. So in order to factor, you have to use all of your different methods of factoring. Now, looking at this first one, some people chose to distribute the square to everything and combine like terms, and that does work. However, there is a shorter way. If you're looking at these, this first term is a quantity squared. This last term is a quantity squared. So if I did 3x squared and 2x minus 1 squared, what I can do is I can factor by using the difference of two squares. So I'm going to have 3x as my first term and 2x minus 1 as my last term. And I'm going to have 1 plus and 1 minus. So then what I can do is I can combine like terms. It would be 5x minus 1 and then x. Careful with this one, you want to distribute the negative sign. So x plus 1, and neither of these factor further, so this would be my answer. The next one's going to be somewhat similar. The x squared plus 1, though, we don't really like that, so we can call this a variable. I saw some people use a. So if we change this to a variable, a is x squared plus 1, this now is much nicer to factor. It would be a minus 5 and a plus 3. And if I then replace a with x squared plus 1, I would end up with x squared plus 1 minus 5 and x squared plus 1 plus 3. This gives me x squared minus 4 overall and x squared plus 4 overall. And the last thing to do is that first one can be factored using the difference of two squares. So if you were trying to use different methods of factoring using distributive property and stuff, sometimes that will work, but sometimes it won't, depending on what your answer is when you distribute it. Sometimes it's going to be too complex for us to factor at this moment. Later, we would be able to factor that. But if you use your substitution or your difference of two squares, the factoring becomes a little bit shorter and it lets us factor things that we might not be able to factor otherwise. So hopefully this helps. I'd be happy to answer any questions you have going over this at any time. Thanks.